Hey guys, and welcome back to another video on the channel. In today's video we're going to be looking at an application of differentiation, a maximization problem in this particular case, and we'll be looking at example 22 here pretty much. So let's get straight into it. So from a square piece of metal, the side length of 2 meters, 4 squares are removed as shown in the diagram below. The metal is then folded along the dashed lines to form an open box with a height of x meters. And then question A is like, show the volume is this. B, find the max value of x and maximize the volume. C, sketch the graph. And then D is applying a restriction. Okay, so what we know is that this is 2 meters here. So not this, just that thing here, okay? Because then 4 squares were cut out. So the 4 respective squares are here, 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 and here, okay? And we're told that they have a height of x meters, okay? So that means this needs to be x, okay? So if that was 2 meters and that was x, and since there's a square, that's also x. That means the actual side length here is actually 2 minus 2x, because you have an x here and x here that's been taken away, so you have 2x, okay? So that means the length is 2 minus 2x, and the width is also 2 minus 2x, okay? Because it's a square. And the height is just x. So if we want to find the volume, volume is length times width times height. So volume is going to be 2 minus 2x multiplied by 2 minus 2x times by x. So all we've got to do is pretty much expand this expression here. So multiply this to that, this to that, this to that. And we'll just leave the x for now. So you're going to get 2 times by 2, which is 4. 2 times by minus 2x, so you're going to get minus 4x. And then you get the same thing here, so you get minus 4x here. Then you have minus 2x times by minus 2x, so you're going to get positive 4x squared times by x. And that's your volume. So what we can do is add the like terms. So your volume is 4x squared minus 8x plus 4 times by x. Then you can distribute that x, so you get volume equals 4x cubed minus 8x squared plus 4x. And you can see we've got the exact expression we wanted in A, because it's to show that question, okay? Righto. Now question B is asking, find the value of x that gives the box its maximum volume, okay? So show that the volume is maximum for this value. Okay, so what this pretty much means is, this equation here, it's some cubic. Now we know what the cubic actually looks like, because if we were to rewrite it, the volume is just simplifying this. It's just 2 minus 2x or squared times by x, okay? So that means we know what this kind of looks like. We know it goes through 0, because if you were to set this equal to 0, so this was volume against x. We're actually kind of doing question C here, but it's still going to help us with question B. If you set that equal to 0, you've got this scenario here pretty much. So we know that x has to be equal to 0, and we also know that 2 minus 2x needs to be equal to 0. So we also know it goes through x equals 1 as well. So it goes through here, and it goes through here. Now I don't know what actually happens in this bit here, but I'm pretty sure it peaks like something like that here, because it's a cubic, it's in its nature, okay? And I know it's going to go up like this, rather than this way, because it's a positive x cubed, not a negative x cubed. So that's why it doesn't go like that. So I know the curve is going to kind of look like this, okay? Now there is going to be a maximum value here. So this maximum value, this value of x, whatever it is, gives you the biggest volume you can have on the curve pretty much. So that's what we're trying to find. Now as we can see here, this is a stationary point. And the way to find a stationary point is you need to pretty much set the derivative of whatever your function is with respect to that variable to 0. So what this means is, at this particular point here, this is when dv dx equals 0. Okay, so we got v here, so we have v equals 4x cubed minus 8x squared plus 4x. Now we're going to differentiate this, so you get dv dx equals, bring that 3 down the front, so we're going to do the power rule for each of these here. So 4 times by 3, that's going to be 12. Subtract the power by 1, so you get squared. Bring that 2 down the front, so you get minus 16x, and then you get a plus 4 there, okay? Now you're going to set that equal to 0, because a maximum is when it's equal to 0, and a minimum is also when it's equal to 0. Now, we have to show it's a maximum or a minimum. So, in order for that to be true, if the second derivative, so if the second derivative with respect to x with volume, if whatever the x value is, if it's positive, it's a minimum, okay? if the second derivative, whatever it is, whatever that number is, if it's negative, then it's a maximum, okay? So we need to show that bit as well, potentially, okay? So let's move this guy out the way now, because we don't need that. We just need that fact. So, saying this equal to 0, so you get 0 equals 12x squared minus 16x plus 4. As we can see, it's a quadratic. So if we want, we can use a quadratic formula. So we can go, alright, x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. Now a, b, and c are the coefficients of these corresponding here. So a is 12, b is negative 16, and c is positive 4. So if you start substituting this stuff into here, what we're going to get is x is equal to negative of negative 16 plus or minus the square root of negative 16 squared minus 4 times by 12 times by 4 all over 2 times by 12, okay? Now at the moment this is going to be a bit tricky to work out, okay? So first of all, we need to see if there's an actual solution. So we have to see if this is equal to a positive number or 0, or if it's a negative number. Because if it's a negative number, then no real solution will exist pretty much. Only a complex solution, okay? Which is something we don't really want. So 16, negative 16 squared is just 16 times 16. So a negative times a negative is a positive. So that's the same as just 16 times by 16, so you can just use a multiplication table. So 6 times 6 is 36, so bring the 3 up here, carry the 6. I think that's how you say it. I don't really care the lingo, it's how you pretty much do it. Then 6 times by 1 gives you 6, add the 3 gives you 9, cross that out. 1 times by 6 is 6, and then 1 times by 1 is 1. So you're going to get 6 plus that 1 there, so you're going to get 5. 256 is 16 times 16. Now, because I'm controlling the video, I'm going to double check that's correct. Yes, it is. And then we got to do 16 times 12. So this bit here, 4 times 4 is 16. So that means 4 times, so negative 4 times by 12 times by 4 is the same as negative 16 times by 12, okay? So do the exact same thing. So just go negative 16. So we know it's going to be a negative number because it's just one negative being multiplied by a positive. So we'll just add the negative on the end. So 2 times by 6 is 12, so 1, and then put the 2 there. And then 2 times by 1 is 2, plus the 1 gives you 3. Cross that out. 1 times by 6 is 6, and then 1 times by 1 is 1. So you get 2, and then you put a 9, and then you get 1, 9, and 2. But that's going to be negative because we have this negative in here. So what we have is 256 minus 192. So 256 minus 192 gives you 64, okay? So we've got x is equal to 16 plus or minus the square root of 64 all over 24, okay? Now the square root of 64 is 8, so your x is equal to 16 plus or minus 8 all over 24. So this gives you two solutions. So your x equals 16 plus 8 divided by 24. Hold up, sorry, 16 plus 8. So you get 24 on 24. And then you also get 8 on 24. So these are your two solutions. So you get x equals 1, and then you also get 8 on 3, so you also get a third, okay? So these are the two values. Now, the reason why I know which one's the correct one, we got one here at x equals 1, and we also got one here at x equals a third, so about halfway. If you plug in x equals 1 into our equation here, so if you put in x equals 1 into here, this bit will be 0, and it also makes sense because it's 0 here as well, so that is not a valid solution. So the maximum value is that x is equal to a third, okay? Now we can actually work out what that is, and we can also see if it's a maximum as well. So we know that's a stationary point. Now we're just going to show it's a maximum. So that means you take the original differential here, so take this guy here, copy, because I can do that, move it down here. So now we differentiate this again. So you get d squared dx. So bring the 2 down the front, so you get 24x minus 16, and we have x equals a third, okay? So if we were to plug this in now, so if we go the second derivative of volume with respect to x at x equals a third, we're going to get 24, so 24 times by a third minus 16. and that's going to give you, it doesn't matter what the number is, I know for a fact it's going to be negative because you're going to get 8 minus 16, so you're going to get negative 8. But the point is, it's negative, so the second derivative at the stationary point is a negative, so that means it must be a maximum, okay? So we know it's a maximum. Righto. Sketch the graph, we've already done that technically. X equals, second derivative. We could work out the y value if we wanted to here, but it's not really necessary. If the height of the box must be less than 0.3 meters, so x can't be greater than that, what will the maximum value of the box be? Well, 0.3 is smaller than a third, because a third is 0.333 recurring. So this is slightly smaller. So whatever the x value is at 0.3 will be the maximum value. So you'd have to plug that in. So if we just take our volume equation, so volume, I actually can't remember what it was, it's up here somewhere, 4x cubed minus 8x squared plus 4x, and you plug in x equals 0.3, so you get volume at x equals 0.3. We could actually write that in terms of function notation if we wanted to. 0.3 equals 4, 0.3 cubed minus 8, 0.3 squared plus 4 times 0.3. Okay, so I'm just going to plug that in for you, so I'll give you a final answer for that. 0.3 cubed minus 8 on 0.3 all squared plus 4 times by 0.3. So you get 0.588. That would be the maximum volume with this restriction if it can't be bigger than this, because a third is greater than 0.3, because a third is 0.33 recurring. Okay, but that's how you'd answer this particular question here. Okay, I hope you enjoyed the video and I hope you learned something. If you did, like and subscribe, and I'll see you in the next one.